Hi, good morning, good evening, good afternoon. First of all, thank you for joining this session. And today we are going to see how to spin a end-to-end digital twin solution under 30 minutes using Boodskap NoCode.build platform. So I'm going to share my screen. Just hang on a second. வரலையா? So I'm logging into NoCode.build online portal. And first time users, you can go ahead and register yourself, and it's absolutely free. And I'm going to use one of our demo account to demonstrate this application. So I'm logging in, and it all starts from something called device models, right? So when you are about to develop a solution for IoT, M2M, or digital twin, uh, you should be modeling a hardware into a virtual software. That's all about digital twinning, right? So in order to do that, you need to create device models. So device model is nothing but whatever your hardware and hardware parameters that can be dynamically created as a virtual software as digital twin in the platform. So today I'm going to demonstrate with a very simple example of a heavy equipment they used to call JCB, and I'm going to add that. So let's give it a name called JCB, and probably some description and tags. And typically, when you're dealing with hardware, the firmware engineers or the hardware manufacturers typically will have a spec sheet which will have model, make, version, and extra metadata and stuff like that. So for now, I'm going to give a simple description of those. Make is also JCB. And now here is the interesting part. So think of something when you are dealing with a hardware equipment or a sensor or an actuator or a device. All we are trying to do is to capture the data and process the data and then visualize the data in various form. That's the core fundamental concept of any digital twin platform. So, so this is something you have to work around with your hardware team to identify what are the different parameters your hardware is going to send to the platform. So in this case, we are going to presume certain things. And let's take an example of a fuel tank. Probably any heavy equipment, we would want to have a live utilization of your fuel, and then probably the engine status, and then whatnot, carbon emission from your air filter and stuff like that. So let's go ahead and add that. First parameters I'm going to add is fuel, and description I'm going to give us a fuel in percentage. So label I'm going to give us label is something this will be displayed in the screen for the end user, and this parameter will be obviously at since it's a percentage, we would expect something between 0 to 100, right? So I'm putting that as a number, and default value is 0. And I really want to enable time series for this fuel. See, time series is nothing but a graph visual representation which will show you on a specific time what was your fuel left in your fuel tank. So this will give you a nice representation in a graphical form, and those are all done automatically when you simply enable this flag. So I'm adding this fuel, and then I'm going to add something called engine status. engine state, I'm saying that 0 is off, 1 is on, and 2 is probably engine fault. So giving a label, and this one is also a number, so default to 0. I don't want any graph here. It's just a a number which represents either the state of the engine. So I don't need to know the historical event for this parameter. And let's stick with one more parameter of CO2 emission from the silencer, which will give you a status of how frequently you need to change your air filter, or how frequently you want to do the preventative maintenance of your heavy equipment, something like that. So in this case, CO2 typically, in a normal heavy equipment world, under 400 ppm would be an acceptable value, and between 400 to 1000 would be acceptable range, and 1000 to 2000 is kind of moderate. Anything above 2000 is hazardous. So based on that, I know the platform will recommend you certain things. That's what we're trying to achieve here. So carbon dioxide emission from engine. So this is also a number, and I'm going to add that. That's it. At this point, we have collected the basic information, the parameters, and we are good to go. I'm saving and proceeding to the next. And this one, I really want to give you a small visual appearance to the new JCB. So I'm uploading an image. I've already pre-made an image for this device. So this will appear nice and neat in the UI. So I'm adding this, and I'm saving and closing it. So if you notice it, a new device model JCB has already added, and typically speaking, this should be enough to get it started. Without adding any more condition, alarms, or events, we can actually start sending data and see how the data appears on the twinned platform. So every user, each and every an account will have a separate a domain which will have the data separated, and you will have a separate login to that particular instance of digital twin. So you can click this user portal link, and you can log in here. First time users, they may have to go and register themselves under this particular domain, and this is typically the end user portal. The NoCode.build is actually will be used by the developers or the designers who want to really create a digital solution, and the twin.digital is the platform where your customers or the end users will go and log in and see the actual outcome of the product. So since those are all pre-built, I'm going to use the same login. If you're new to the platform, you can go and register yourself. So I'm logging in here. I don't see the newly added JCB because the data is not available yet. We just created the model, and now we're going to go and simulate some data, and then we'll see how this looks in the portal. So in order to simulate the data, you should go to the device section, and in this case, I'm picking the JCB, and I'm going to create a physical device. This is the place where you actually go and attach the physical device with a virtual twinned model. Now we have an UI to do that, and also for enterprises, also for people who deal with lot of different kinds of devices, we also have an API layer where you can go and automate this entire process as well. So here I'm going to give a simple name as my JCB, and the hardware ID is something you have to refer to your hardware manual. Every IoT gateway or IoT smart sensor or smart equipment manufacturer will give you a real physical hardware ID. This is kind of an equivalent to a MAC address or BLE MAC address or something like that. So this will be a unique ID which will be assigned for your hardware, which will correlate to this twinned software. So I'm just cooking up some value here with 005674, something like that. So I'm creating this, and this is all you need to get it started. Now, in order to really integrate with your end hardware, you can go and look into this section where how to actually send data to the backend platform. So as of now, the twin platform will accept data through many channels. The most commonly used channels are MQTT and HTTP, and we also support different kinds of protocol. If your device is LoRa enabled, we have LoRa WAN gateways, and if you are into old generation of device like UDP datagrams, we also support UDP datagrams. And if you have TCP socket based data, the platform also supports that. Practically speaking, we have more than a dozen of the end protocol implementations. But after 2020, most of the industry got standardized, and a lot of people are using MQTT and HTTP as the standard data transmission layer. So this is where this is your unique ID for this particular device, and this is a token, and you can regenerate it as well. So using this token, you can start pushing data from a real hardware. So right now, it virtually is impossible for you to show the real hardware. So I'm simulating the data using this tool. So since we added 3 parameters, all these 3 parameters appears here, and I'm just giving some random value. Let's say that your fuel tank is about 80% full now, and an engine is running, and CO2 probably 300, which is well within the range. I'm setting it. So the data got sent, and if you go and look into your devices, a new JCP appeared here, and the automatically you would see only one data as of now. Now the advantage of this particular view is when you actually develop an IoT product or a digital twin product, you would spend a lot of time in figuring out exactly what is going on with your data. So we have made it very nice and neat that when you are integrating with your physical hardware, your team can go and look into the actual data and make sure that the data is the one you are looking for. If there is any errors, you can go and work with your firmware team and make sure the data is correct before you go to live, right? So we have various different views to see the data. This is one view, and we also have a grid view. If you are dealing with hundreds and thousands of different kinds of devices, you will have filters and you have search, and that will appear in this particular tabular format. And obviously you can expand it at any point in time. You can go and see what exactly the data was, and you can pick a particular device and get the historical data as well. So let us go and add more alarm and display to the twin, so it has more meaningful data represented in the visual format. So I'm going to go here and introduce something called conditions. So condition is something, think of something like that. What do you want to do? If fuel goes out of range, do you want to get it notified, or do you want to show visually, or do you want to raise an alarm or sound or something like that? So the platform has something called condition, where you can go and create one or more conditions, and using the conditions, you can articulate various workflows. So in this case, let's say I'm going to create a condition to display the fuel in the visual representation. So I'm going to say fuel range, and in JCP, if fuel between, let's say, 0 to 100, this condition will be satisfied. So that's the meaning of it. So typically this is, we are trying to this interface is very similar to if interface. So basic permutation combination kind of thing. So if this thing happens, what do you want to do next? if a multiple of this thing happens, what do you want to do next? So you can have hundreds and thousands of different conditions, and you can combine all these conditions and create a complex conditions, which I'm going to show you right now. So I just created a fuel range. Let's go to a section called display and create a fuel display which will appear on the the visual interface. So I'm going to add a fuel display called fuel range, and let's go and select the parameter. So in this case, we are going to show the percentage of the fuel. Typically, if you look into a car dashboard or any vehicle dashboard, you would see the fuel range, right? That's what I'm trying to build it here. So I'm picking fuel, and I'm going to give this border as let's say rounded border, and I want a background color of probably some greenish, and the text should be in the black color. You can change a lot of parameters. You can give a prefix, suffix, something like that. In this case, the condition will be, we just created only one condition. I'm just picking the fuel range. That means whenever the data received by the platform, if the platform detects that the fuel range is between 0 to 100, this display will be automatically placed in the visual representation. That's all. And we can optionally add a tooltip to that. So fuel level in percentage, something like that. So I'm saving this. So we saved this display. Now let's go and simulate one more data. And so this time I'm saying, say fuel, let's say last time we selected some value. I'm going to reduce the fuel. Engine status is running, and CO2 probably some 350, and send it. So if you come back to the digital twin dashboard, so you see the fuel automatically appeared here. So you can create a number of displays. See, typically, the problem the digital twin platform trying to solve is, see, when you are developing an IoT product, your end customer probably needs 2 or 3 basic functionalities. For example, a smart air-conditioned manufacturer, they may produce a small mobile or tablet application where your end customer can go and control the air conditioner. But in order to deliver a small smart application, you may have to deal with the load amount of data in the background. And today, a lot of companies are spending a lot of time and energy and money to build the ecosystem for only the purpose of understanding the data, tweaking the data, so they can serve their end business very effectively. So Boodskap digital twin platform will completely cut down this time to market. Instead of you reinventing the wheel again and again for each and every product, you can separate out your non-functional business data into this digital twinning application, and you can only focus on building your end user application. So in this case, your back office team can all the time go and look into data consistency and diagnostic data. So think of a very complex scenario where your devices sends like hundreds and thousands of parameters. So based on the hundreds and thousands of parameters, you can build a cool looking UI. So your backend team can go and validate your end customer application is running properly and smooth. In order to do that, you may have to go through a mountain of hurdles to integrate with your physical hardware and try to build a software on top of it. That is completely super simplified and given us a very simple interface. Now, this is not the end of it. I'm going to show some other things as well. So we talked about display. I really want to show you something called alarm. The difference between a display and alarm is, display is something will demonstrate the value received by a sensor and represent it in a UI snippet, where alarm is something you can have multiple states and you can show, for example, what do you want to show with the UI when your engine is off? When it is running, you may want to show a different icon. When it is in an engine fault state, you may want to notify the user with a red mark saying that, hey, something is wrong with your engine, so you can proactively go and fix it before even your customer notice that. So let's go and do that quickly. So in order to do that, I'm going to add a couple of more conditions here. And in JCB, if engine state equal to 0, I'm going to say engine off, right? And let me add one more condition, engine on, and if engine status equal to 1, I'm going to call that as engine on. And one last condition, engine fault. Engine state, I'm going to say greater than 1. Any value greater than 1 will be considered as engine fault for now. So out of these conditions, let's go to alarm section, and I'm going to add a new alarm saying engine status. So let's go to this condition and add a state to the alarm. So we may want to add 3 different states, right? So first state will be obviously engine off, and I'm picking the condition of when engine off, and I'm going to give a tooltip of JCB is not running, and adding one more state of engine on, and in this case I'm picking engine on, and JCB is running. And let's add the final state of engine fault. I'm picking engine fault. And the thing is, you can have multiple conditions in a group as well. The way you differentiate, for example, you're dealing with a very complex scenario, saying that, hey, my diagnostic data is some value, and my engine status is some other value, and some other parameter with a different value. You can combine all those rules, and you can either pick match any or match all. So match any means if you pick multiple rules here, the platform will automatically put the status if it matches with any of your condition. Match all will make sure if all of this condition matches, this state will be represented. As simple it is. So in this case, we have a very plain, simple 3 use cases, and I'm saving it. And let's go and simulate one more data here. And let's go to devices. I'm simulating a data. So in this case, fuel, let's say 22, engine status, I'm going to say 3, which is engine fault, and CO2, let's say 350, and send it. So now you go back to your portal, you automatically see the engine state appeared here without you doing anything. So this dashboard is actually a live dashboard. You don't have to keep refreshing or anything. So you can build live dashboards which will actually represent your tinned digital hardware into a virtual software here. And you can add n number of alarms, n number of displays, and many more things. And this will automatically display it here. Now, like I said, you can go to historical data and see what happened. And 7 minutes back we got it, and a moment ago we got a new data. And this is where you can go and see your trend as well. So in this case, we started with fuel 80, and then the fuel got 35. Now the fuel is some 22. So look at the power of the visual representation here. You have multiple filters. If you are dealing with a large amount of devices, large amount of data, monthly, weekly, yearly, quarterly, you can filter with the data. So this will be a very handy tool for you while you are either developing a new product or you are migrating an existing product into this platform. So in about a day to 2 days, you can configure your entire application, and then you can go to market very confidently and very, very swiftly and fast. So that's the overall thing. Now let me talk about a few other things here. We also support location-based applications as well. This is still in beta mode. As of now, we will only show the live location of devices. Let's see that your devices needs. Assume that you have a trackable device, which is a movable asset, and you can obviously enable the hash location. And in this case, I'm going to simulate a location. See, typically, the reason I'm simulating right now is you all know that it's a live demo, and it literally is not possible for me to really hook up with the real hardware and show you. But we all understand the API world, right? Whatever possible through this UI, it's all possible through the API. So we have API layer where you can actually broadcast your current location through the API as well. In this case, I'm just picking a random location and sending it, and you will automatically see my JCBs here. So this view is also a live representation of your layer. And very soon we are going to introduce geofencing. We're going to introduce a distance from one point to other point. You can calculate the ETA, estimated time of arrival, and a lot of other functionalities over the period of next several weeks. We are going to roll out into this map module as well. So I'm going to simulate one more map data completely in a different location. And yeah, I'm selecting this, and you go back there, so it moved that. So I can keep showing you many other options in the platform, but we have plans to demonstrate various portions of this software in next 6 to 8 30-minute sessions like this. So we will cover each and every section in depth, so you can go to market with any of your new idea, or if you are struggling with your existing platform or existing implementation, reach us out. We can guide you to go to market very quickly and swiftly. And yeah, like I said, it's almost 30 minutes, and we started a complete different new digital product from the scratch. And we quickly demonstrated by simulating the data and showing you real time as well. And I really thank you all for attending this webinar. And I hope that this tool will be useful for most of you. And feel free to reach us out with any questions. It is absolutely free for you to go and try it out. And we have a 30 days trial period. And obviously, we can extend the trial period by case. And if you are a startup, if you are a student, if you are a university, reach us out. We have exciting plans for you. Students will get 100% discount, and universities and colleges, we are giving out a lot of discounts. And for startup, we have exclusive premium plans, and also we have different pricing plan for different demographics. If socially, economically, suffering demographics, we have a very simple pricing model. And we also participate in partnering with exciting startups. And if we believe that your startup is very, very cool, and we will give out the platform for free. So we are also a startup, and we are exploring it. And we have developed the platform. The core IoT platform was developed last 4 years, and it's been time tested with millions and billions of data points. And that's the reason we recently came up with this top layer for the invisible platform. And the next few months is going to be very exciting. And every week we are going to see a lot of additions into the tool sets. And I really wish all of you to give it a try. And please give us your valuable feedbacks and comments, so we can either incorporate or we can fix what you are looking for. Thank you all, and have a good day. Bye.